Yeah, or it's a product of a number and one or more variables. Okay, so that's what we're doing. We're dividing by those. And so last week we talked about multiplying, which was a lot of addition. So if we're doing dividing, what operation do you think we're dealing with today? Subtraction. And we have to be really careful because it can really throw us off if we're not actually subtracting when we need to. So let's start with an easy one here, 2 to the 6th. And I need you guys to copy everything I'm writing up here because it helps you not only do it, but understand why you did it, which is more important than just doing it. Okay, so 2 to the 6th divided by 2 to the 3rd. And this is a fraction, but it's also division. So I hope you can see it both ways. I'm going to do it the long way. How many times is 2 being multiplied up in the numerator? 6 times. Okay, 1, 2, 3, 4, 5, 6. And how many times in the denominator? 3 times. 1, 2, 3. Okay, if I were trying to simplify this, make this as simple as I can, how many times would I cancel out 2? 3 times. Okay, now when I cancel out, just a reminder because you're going to see this later on, 2 over 2 is equal to what? 1. So it's not like it just disappears into nothing. It is actually 1 times 1 times 1. But what's my final expression here?
2 to the 3rd.
Good. 2 to the 3rd power. 2 to the 3rd power would be my final expression. I can do all these problems like this. Just write out the multiplication, cancel out any common factors, and I'm done. But do you guys see an easier way to do it? Josh?
Like, take, if it's like a common, like the base is
Yes.
like a common.
Good. If it's a like base, so same base.
Then you can subtract the bottom one from the top, like the bottom product.
Exponent?
Exponent from the top exponent.
Okay, so listen carefully. If you are dividing like bases, these two numbers are the same number, 2 and 2, for example, you can subtract those exponents, 6 minus 3. So what's 2 to the 6 minus 3? It's 2 to the 3rd, which is exactly what I got over there. That's how you simplify these. This is the most basic thing you will deal with in this lesson today. So make sure you're writing this down. All this written down. Okay, this will lead us to our first key concept of the lesson. It is the quotient of powers. So what does quotient refer to? Division. Okay, so we're dividing bases we're talking about. A to the m divided by a to the n. Can anyone give me what that final simplified result would be? Wyatt? A to the m minus n is correct. There you go. That's a simplified. If you're dividing like bases, you can subtract those exponents. You get your final simplified version. Okay. So let me give you one, see if you guys can get this one. How would you simplify s to the 3rd divided by s? S to the 3rd divided by s. What would you get as a simplified version? James?
Like completely solved?
Yeah, well, and when we mean simplified, I only have one s in my problem, in my answer. So how would I make this as simple as possible?
S to the s squared.
S squared. Okay? Whoa. I get the s part. How'd you get 2? Oh, that's right. There's a 1 right here. And so what did you do to find the 2? 3 minus 1 equals 2. S to the 2nd. That's it. That's all you're doing on that. Okay. Let's look at example number 1. And let's see it when it gets a little bit more complicated. Not badly. Example number 1. Y to the 4th times z to the 3rd divided by y to the 2nd times z to the 2nd. Okay, a lot going on here, but let's see if we can take it one step at a time. Josh, you made a very important point that we can do this shortcut method with dividing when you are dividing like bases. So can I combine y to the 4th and z to the 2nd? Can I just like yz to the negative or yz to the 2nd? No. But can I combine these two together and combine these two together? And the answer is yes. So let's take it separately. What's y to the 4th divided by y to the second. Y to the second, because 4 minus 2 is 2. So that's how I simplify the y's. And how do I simplify the z's? Well, 3 minus 2 is 1. So you can write a 1 or you can leave it alone. That is your simplified version. Does that make sense? You guys okay with that? I would hold the applause for later, because it does get a little trickier. But you guys get this part right here? Oh, yeah. You guys okay here? We're taking one step at a time. Okay. Simplify this expression. B to the fourth divided by B to the fifth. Yeah, no, I don't want to know yet. Just figure it out. I might get a variety of answers here. Hopefully they're all the same. Okay, if I'm using my quotient of power rules, isn't it, since we have the same base and they're being divided, can't I just do 4 minus 4 is equal to 0? But if I looked at b to 0, I'm thinking to myself, what does that even mean? Okay, well, let's take it over here. I'm going to separate it. B to the fourth over B to the fourth. I'm going to work out that long way. How many times is B being multiplied?
4 times.
1, 2, 3, and 4. How many times is it being multiplied down there? 4 times. Okay, great. All that work to say, what cancels out? Everything gets canceled out. These two, and those two. But tell me what was left over. It's not just disappear into nothing. It becomes, oh, good, 1 over 1, which equals 1. So here, I'm left with 1. So you know what b to the 0 equals? 1. B to the 0 equals 1. It's worth 1. Yeah, if you know what b is, you raise it to the 0 power, it's going to be 1. So 5 to the 0, 1. 100 to the 0 power, 1. Because if you put 100 here and here, they're going to be the same thing. And there's another reason why it's 1. Yeah? Great question. 0 to the 0. Uh-oh. You know what that equals?
0.
I don't know.
Undefined?
Undefined. Yeah, you can't. Good question here. You can't have 0 as your base. So you can't have it to the positive exponent, negative exponent, or 0 exponent. There's no value here. I don't know how to write. Okay, let's keep going here. Good question, though, because, all the definitions say if A is any number other than 0, it cannot be 0. Okay. Here's the second important thing, and we kind of already dealt with it, but just so you have it in your notes, whenever you have a 0 exponent, this is the rule you have to follow. Okay, ready? It's complicated, so make sure you write it correctly. So we're going to use A, which does not equal 0, anything but 0, to the 0 power equals 1. And that's it. That's it. Anything to the 0 power equals 1. Okay. All right, next one. Simplify this expression, b to the 6th, c to the 5th, over b to the 6th, c to the 2nd. Don't tell me what the answer is. Just simplify it. Question?
If you put, they're trying to trick you, say a over 0 and then divided by...
Sorry, a to the 0?
A to the 0 divided by a to the second. They want to trick you to say, a to the negative 2. That doesn't work, does it?
Great. That's a really good question. I will answer it soon, because that's a good question. I'll actually spend a few minutes on that. Okay, but I'm going to deal with the b's, because they have the same base, and these two have the same base. So what do I get with b to the 6th over b to the 6th? It's just worth 1. So you can write 1 if you want. You don't have to. But then with c to the 5th over c to the 2nd? C to the 3rd. So 1 times c to the 3rd or just c to the 3rd. Either one is acceptable. You guys okay with this so far? Okay, remember how I said it's going to get a little more difficult? We're going up here. It's just little by little going to get more difficult. All right, Wyatt asked a great question. I'm going to give you one similar to this, the one he asked. R to the third divided by R to the seventh. What's that worth? Use the quotient of powers rule. So, you get R. Good, you get the same base. To the negative fourth power. Huh? Okay, I don't know what that means. Just by looking at it, I'm like, okay, 8 in there, that's great. So I'm going to go the long way and see if it can explain this right here. Okay, so R to the third over R to the seventh. How many times is R being multiplied up top? 3 times. On the bottom. 3, 4, 5, 6, 7. Okay, how many times does R cancel itself out? 1, 2, 3. Okay, now this is where this is why I emphasize some things. What's all this in the numerator now? 1. It's not just 0 or nothing. It's 1. And then what's in the denominator? R to the fourth. So if I work it out using that quotient of powers rule, I get R to the negative fourth. If I work it out old school way, I get 1 over R to the positive fourth. Wait, could this have 2 different values? No. That means this. R to the negative fourth is equal to 1 over R to the positive fourth. Ooh. And this is tough, and I'll see if I can explain it a different way because I think I could have done better last year. But let's look at it this way. Okay, R to the negative fourth. Can you guys say it's over 1?
Yes.
Okay. Do you guys notice these 2 numbers? And there's a word that can explain them. Do you guys remember when you flip the numerator and denominator?
Yeah.
What's that called? Reciprocal. So you guys see how these guys are reciprocals? There's one big difference, though. What happens to that exponent? It goes from negative to positive. So it's the reciprocal of... Great question. Now, when I'm talking about negative exponents, do you notice that the actual sign of the outside number, like this number right here, it's not, what's the sign out here? Sign. Positive. What's the sign here?
Negative.
Still positive. The positive negative is not affected. It's only that exponent that's affected. And let me show you an illustration here how that works. Okay, ready? Let's look at a pattern. What's 2 to the fourth? What's that worth? What's 2 times 2 times 2 times 2? 16. What's 2 to the third? 8. 2 to the second. 2 to the first. 2 to the 0. Okay, do you guys see the pattern? I'm dividing by 2 each time. Now here's where it's going to get tricky if you're not thinking about it. Don't I drop to negative 1 here? What's that worth? Well, what's 1 divided by 2? 1/2. Now,
it's not a negative number.
It's not a negative number. It's a reciprocal. Now let's keep going. Watch here. It's okay. I'll show you here a little similar.
Negative number would not make 2 a negative.
Hold on. It's not a negative number. It's just the exponent.
So it'll never be a negative number. It'll just turn into a really, really small.
Okay, ready, guys? This is the pattern. Do you guys see? 16 divided by 2 is 8. Divided by 2 is 4. Divided by 2 is 2. Divided by 2. Divided by 2. Divided by 2. But watch this. Ready? Look at this number right here. And this number right here. 4 and 1/4 are reciprocals of each other. So can I give you a quiz real quick? Okay. What is the value of 2 to the negative fifth? What's that actually worth? 1 over 32. Like, how does that? Well, can somebody tell me what 2 to the fifth is? What's 2 to the fifth? It's 32. So 2 to the negative fifth should be?
130.
Yeah, see how they're reciprocals of each other? That's what we mean by those signs. They're reciprocals, not positive, negative switch. It's tough. We'll get more practice. Okay.
I understand now.
And if you don't fully understand it, it's okay. This is the first time in 8th grade. I think you guys maybe understand it a little bit more than 7th grade, but it still takes time. This is hard. Yeah, we did go over it, and it was tough. So the last thing I want you to get, the last main key concept would be negative exponents. A to the negative n is worth, could someone give it to me in reciprocal form?
1 over a to the n.
Good, 1 over a to the positive n. That's it. This is cool, guys. This is really cool. It's really going to help you with your care. It's like, are you going to be careful with these problems? With signs and reciprocals and exponents and dividing and subtracting
Wow.
and multiplying and adding and raising to a power. All in one problem. This is cool. Yeah, and this is going to tie into geometry because you do deal with this stuff here.
Oh my gosh, look at that. What about
Go to page 504, and let's just do number 10. Let's go back a couple steps. A to the 4th times a to the negative 7th times a to the 0. Okay, just tell me what you get, and then I'll explain what I want on these answers, because it depends on what we're asking for your final answer, but I'll clarify that. Okay. These bases are all being multiplied. This is a review of last week's lesson. They have the same base. So what do you do with those exponents here? We're not dividing, are we? So what do you do with these exponents? You
Add them, but anything.
add them.
Isn't it like anything multiplied by 0?
That's not true.
Okay, this is what you're doing. You're going to keep a as your base. What's 4 plus negative 7 plus 0? Negative 3. Okay, this is what we get. You had the like base. This is last week's lesson. You're multiplying these together, right? There's no number over the other number. So you add those exponents, you get a to the negative third. But in order to make it fully simplified for us, you need to not have negative exponents in your answer. So can anyone convert? I'll tell you why. A couple reasons.
1 to the 8.
It becomes 1 over a to the third. That's the simplified version. Yeah, you're going to have to make them positive. Okay, here are a couple reasons why. There's nothing magical about a positive exponent. It is easier to look at. It's very easy to look at. In fact, in Algebra 2, when you get more difficult, I would ask you, write all your exponents as negative exponents. Or write them on the numerator or on the denominator. So I'm going to give variety, but for this lesson in our class, all you have to do is get them into positive form. That helps us to realize I can rewrite this as its reciprocal, and then I get a to the positive third down there. So it gets us practice moving them back and forth. And it does get tricky, but that's the whole point of this lesson, is to help us to think and work through this better. Okay, next problem is number 11, the next one over. 6r to the third over r to the 7th. Okay, remember you have to deal with like bases. So I'm going to deal with the r to the third divided by r to the 7th. The 6 is kind of on its own because it doesn't have a like base anywhere here. So 6. Okay, so I get 6, and I get r to the...
1 r to the 4.
Okay, great. Give me just your first r to the what? What's r? Okay, you would get this, right? But is that how we leave our answer? No. So what you have to do is think through it, or you can kind of go through this step a little bit differently than I do. It's okay. So 6 times, what's r to the negative fourth in reciprocal form? 1 over r to the fourth. The 6 is still by itself. You don't mix it in that problem because it gets tricky. And you're like, what do I do? That's okay. What do you do here? 6 times 1 is 1 times r to the fourth. This is your simplified form. Did the 6 move, by the way? No, it was always in the numerator. Numerator, numerator, numerator. What did have to move? R to the negative fourth into the denominator. in order to get its reciprocal form. So that's another piece of this puzzle. You got to keep the numbers where they belong. Now, does that mean that the constant never moves? No, but in this case it doesn't. Leave it in the numerator. It's good where it's at. Okay, let's go. Oh my. Example number 2. Dun, dun, dun. Oh, and what I'll do here, because we have a little bit of extra time, is I'm going to go through the first part of the homework with you to help give you like a boost on this, because it seems like it's a lot, and it is. But after a while, you do get better.
Example 2.
Okay, I'm going to deal with like bases. So I can deal with the n's. I can deal with the n's. And then I have some other things that I haven't circled. Okay. Does the y to the negative fourth have another like base? Does the y to the negative fourth have any other like base? No.
Yes.
So
y to the 0. Because that equals 1, right?
Where?
Up there.
You're good. Yeah. You're right.
Okay.
I'm good with that.
Okay.
That's good, Walker. That's good. I'll let you keep thinking that way. You're good. I'm not going to teach it that way because it's a little bit, but you're good. All right. Can I combine these two, though? Can I do negative 9 over 27? Can I simplify that? Okay. So I can simplify these first 3 parts. We'll deal with that at the end. Okay. What's negative 9 over 27? Negative 1/3. Very good. See, that was not bad. You got rid of those numbers. You got negative 1/3. That's easy enough. By the way, negative, right? It didn't just change from negative to positive. It's still negative. M to the
Fifth.
good. Wait, I thought it's to the first.
No, because if you start negative, actually added.
Okay, I do 3 minus negative 2, which is 3 plus 2. That's how I got my 5. N to the okay.
1. Yeah, just 1.
Yeah, it would be worth just 1 because what's any number over itself? 1. So n to the 5th over n to the 5th is just a big fat 1. It could drop out, but it's still just 1. Anything times 1 is the thing that you already have. Do you guys notice I have this down here? Okay. Where is this number? In the numerator or denominator? Okay, you guys agree it's down here?
Yes.
Okay, I don't want a negative exponent, so can I move it into the numerator? And it becomes what up here? Y to the 4th in the numerator. Y to the 4th. It's not down here in the denominator. It's in the numerator. Do you guys agree with that? Yeah, I want to get a positive exponent for any of my variables or numbers. Positive exponents. Okay, you can leave your answer like this. That could be your answer. That's fine. Your book is going to write a little bit differently. So if you're checking your book, you're going to look at this one. Oh, man, it's wrong. No. They write it as negative, and they don't want fractions as coefficients, so this is what they're going to put. Let's see if you guys follow me here.
Well, that makes sense. I get it,
Yeah, I get it.
They leave it like that.
yeah.
That's not right. It's not safe.
It is.
So if you see this in the back of your book and you have this, it's okay. You're okay here.
So would the negative change the n and bond in the line before?
This negative? No, and this, listen, I need your eyes on me here to help you out. This negative and any negatives or positives in the exponents, they don't mess with each other. They're not changing each other at all. They're separate ideas. When you have a negative exponent, you're talking about a reciprocal. When you have a negative sign outside, you're talking about negative value or positive value, depending on what sign's out there. So it's different. Yes, sir?
When you brought the y to the 4 to the numerator, did you have to put anything below it? Because you didn't do that.
You could put over 1, but then 3 times 1 is still your 3. Walker, you actually did a good thing. I don't know how you thought of it. That's good.
Okay.
Walker said there's a y to the 0 here. Is that true?
Yeah.
I mean, is there technically a y to the 0? And so what's y to the 0 minus negative 4? y 0 minus negative 4 is positive 4. So you could do that way. That's fine. Okay.
Because I went.
Food for thought. All right, B. The ultimate last final problem. 5p to the negative second raised to the negative second over 2p cubed squared. Ugh. Okay, before you get overwhelmed, just write the problem down. That'll get you at least something on your paper. I did some work, Mr. A. Did you write the problem down? Yeah, I did. Okay, so we're there. I'm going to simplify the numerator and denominator before I start dividing anything. So do you see how we have parentheses with exponents outside? You got to deal with that first. So here on the numerator, you have to be very careful. Does 5 have an exponent?
Yeah, it's a 1.
As a 1. So 5 to the first raised to the negative second would be 5 to the negative second. That's our power of powers rule that we looked at last week. You just do 1 minus negative 2. Negative 2. P to the fourth. Because what's negative 2 times negative 2? Positive 4. That's when you multiply.
Wait, so you multiply that, but you subtract it for the
Oh, no. This, you did 1 times negative 2. That's okay. Yeah, I see what you're saying. Because we're going to do the same thing down here. Does 2 have an exponent? Okay, so what do I get down here? 2 to the second. I'm going to stick with that for now. P to the 6. Good. See, I hear the 6. I hear it. That means you guys are thinking and doing it well so far. Oh, this looks kind of complicated. I know that I'm going to deal with these two, right? I deal with those. And then these numbers, they're tricky. Okay. Can I simplify either one of these right away? Yeah, someone already said it. What is 2 to the second? Okay, ready, guys? Can I do this?
What? You can't do that. It's impossible.
So all I did is simplify the 2 to the second. But that 5 to the negative second,
No.
not negative. But
Oh,
what?
you're right.
It's in the numerator, so where does it have to go now? If it's reciprocal? Denominator. And down here, so if this moves down here, it becomes 5 to the positive second. So I took it away from here, and since we're talking about reciprocal, it goes into the denominator and becomes 5 to the positive second. Does anyone know what 5 to the positive second is? 25. 5 times 5 is 25. So watch this. This is 25. Okay. Yeah, what's 25 times 4?
100.
So we have 100, and then we haven't dealt with this, huh? Okay, we haven't dealt with that. So I still have this. P to the fourth over P to the sixth. I haven't dealt with that yet. Can anyone simplify this right here? P to the... Say it firmly. No. Say what you guys said, just firm.
P to the negative second.
How many of you agree that P to the fourth divided by P to the sixth is P to the negative second? P to the negative second over 100. Yeah, because can we keep it P to the negative second? What do we have to do? If it's up here, where does it go now? Denominator, it becomes P to the positive second. Yeah, that's 100. That's complicated.
Wait, so that makes a 1.
Yes. Yeah, do you see? And it was already there. What number is up here now? If I cross that out, what number's here? What number's down here? So isn't it 1 100? 1 100? So it's there. It's not right away clear when you're working out the problem. Ones are important. Okay, you've done this problem, or maybe you've looked at this problem, and you're like, oh no. Let's just do number 12 on page 504. And this one's a better indication if you're getting this or not. So do number 12. It's slightly difficult, but they did not throw any coefficients. So there are no numbers in front of the variables. I like that, just to kind of stay dealing with these variables and exponents themselves. So this is what I have. Okay, I have to deal with the parentheses first. And so can anyone simplify the numerator? Just simplify this right now. What do I get? A to the 14th, b to the 4th. Okay, that's a simplified version of the numerator. The denominator. Can somebody give me what the denominator is going to be? A to the 4th. What's negative 2 times negative 2? Positive 4. B to the negative 2nd. There you go. Now, is that simplified? No, because I have an A in the numerator and denominator, so I got to combine them somehow. So I'm going to combine these two, and I'm going to combine these two. So what do I get with the A? A to the 10th. Yeah, you're going to do 14 minus 4, A to the 10th. B to the 6th.
Oh, yeah.
Because 4 minus negative 2 is really 4 plus 2, which is 6. Not too bad. Sorry? No, but this is like, if you're getting this, you'll get the easier ones, obviously, but then you'll be able to handle the harder ones. Because they're taking this another step. Okay, I'm going to write up the homework on the board, and I will work them out with you. So you should get the first whatever I'm going to work out correct. And then once I get to a point where I think you can get it, I'll let you go on your own. So I'll start by writing the homework up here. It's 15 to 39 odd. And then numbers 43. Goodbye, son.